Hello, this is Mr. Martin. In this video we are going to take a look at the distance formula. This is really just an extension of what we've been doing with the Pythagorean Theorem. If you see in the picture here, we have a right triangle, and instead of labeling the hypotenuse C, we've labeled it D. So let's take a look at this point down here by the right angle. Since it doesn't have coordinates, it's over the same amount as this point at the top. So the coordinates of this point are x2, comma, and it's up the same amount as this point to the left, so that's x2, comma, y1. Alright, so if we wanted to use the Pythagorean theorem here to find the length of D, I would find out how long the bottom leg is and how long the vertical leg is, and then I would just apply the Pythagorean theorem. So as you can see in the picture, the distance between these 2 points going horizontally is this value x2 minus x1. That's how we find the distance between 2 points. We subtract the coordinates. And then for the vertical leg, we have y2 minus y1. So here's y2, and we're going to subtract y1 from that, and we get y2 minus y1. So we have our A and our B from the Pythagorean theorem. So again, this would be c squared is equal to a squared plus b squared. Okay, and it really doesn't matter which one we let be a and b. I'm just going to have the horizontal section be our a. So that distance there from the point on the left to the point at the right angle is going to be x2 minus x1. And if you have a picture, really, you could just count this off the picture as well. But you just have to subtract the x values. And then for my b, I'm going to subtract the y values. That's the green. So we have y2 minus y1. And then in order to solve for d, we would just take the square root of both sides. So the square root of d squared is d. And then we just take the square root of this whole thing. It looks a little scarier than it really is. Again, it's just the Pythagorean theorem, which we've been working with for quite a while. So there's our distance formula. And again, if you think about it in terms of it just being the Pythagorean theorem, you don't really have to memorize anything. Okay? So let's take a look at example 1. And I like to label these. This is going to be my x1, comma, y1, and this is going to be my x2, comma, y2. And for my distance formula, I just need to subtract the x values and subtract the y values, and then I'll apply that to our distance formula, or Pythagorean theorem if you prefer. So I'm going to have that d is equal to the square root. Okay, I'm going to subtract my x values, and since I'm squaring it, it doesn't really matter if I do x2 minus x1 or x1 minus x2. I usually will do it so that I can avoid negative numbers if possible. So I'm going to do x2 minus x1. Then I'm going to subtract my y values, the highlighted green, and I'm going to do y1 minus y2. Again, since I'm squaring it, 20 minus 16, there's my square. Even if this was a negative number, it's going to be positive anyway, so it doesn't really matter the order that I subtract those. So let's go ahead and do some simplifying. So 13 minus 10 is 3, so that's 3 squared. 20 minus 16 is 4, so that's 4 squared. So I get the square root of 9 plus 16 is equal to the square root of 25. And if you don't remember that 25 is a square number, you can go ahead and do a tree because we want simplified radical form. And we get that the distance between these 2 points is 5 units. So graphically, I'm just going to make a very quick sketch. 1020 might be about here, 1020, and 1316 might be somewhere over here. Again, I'm just making a very quick sketch, and then the distance between these two is 5. And you can see that little right triangle that I used to find that. Here's my A, here's my B, and then I just used the Pythagorean theorem to find my C. Alright, so you can go ahead and try part B on your own. If you want to check your answer, just check in with me in class. And then for part C, it says quadrilateral ABCD is a parallelogram. Find its perimeter. Leave your answer in simplified radical form. Okay, so we have 4 different segments here, and if you remember, with a parallelogram, we have both pair of opposite sides are going to be congruent. So these 2 sides are congruent, and these 2 sides are congruent. So if you find one of each, and then you just multiply it by 2 and then add everything up, you can get the perimeter. Okay, so you're going to, if you want to do it the quick way, find a vertical segment using the distance formula, find one of these diagonally facing segments using the distance formula, and then just multiply those answers by 2, add it all up, and you have the perimeter. Alright, so that's going to be the end of this video. Make sure you go ahead and finish all the other examples and complete the recap it. And if you have questions, make sure that you get those asked, and we'll see you in the next video.